Welcome back. We are talking about molar mass today. This is, according to me, this is page 25. The title is Molar Mass. This is section 4.2. The first one was the vocab, so if you need to get that, you can still get that. That was actually one of our bell works for today. Our essential question is, what is the molar mass of a compound? And how do we calculate? There's our question. So molar mass, again, is the mass of, or the amount of grams, if you will. This is probably better to say the amount of grams, because we don't want to use mass in our definition, of a compound. So we're talking about how much a compound weighs, if you will, except we're not talking about weight, we're talking about mass. So let's kind of review. We got some things to review. So first off, atomic mass. We know this as average atomic mass, and these are those little red numbers on our periodic table up on the wall, or they are the numbers on the very bottom of our periodic table, each element's box. So the atomic mass, remember, is the average of all the isotopes mass. I've taken us back a couple of units. So this is average of all the isotopes masses, right? And where we found it. And where do we find that on our periodic table? Remember, that's the bottom number most of the time. On the two periodic tables that you have examples for, they are the bottom number. It's also the one that has decimals, if that helps you out. Okay, so let's kind of take a little more aside here. We have what is called counting atoms. So we have this compound, ammonium phosphate, right here, ammonium phosphate. And what we're trying to do is I want to know how many of each of the atoms do we have. So if I look at N, how many N's do I have? Hopefully you said 3, because I have that 3. The 3 is distributive, right? So everything in the parentheses has 3 times what it started out with. So 3 times 1 is 3. If we move next to H, 3 times 4 is 12. So we have 12 H's. Hopefully you're kind of following along with this and you're like, yep, this is super easy. Let's keep moving. So then we look at P. We have 1 phosphorus and we have 4 O's. Awesome. So let's take this into how do we do this? So step one, I tried to give you every other one so you wouldn't be writing a whole ton, but also still writing a little bit. So our first step is write the formula if applicable. So if you already have the formula, you don't need to write the formula like up there. We have the formula, so we don't need to write it, okay? Step two then is going to be to separate the formula step that we did just above here. This right here would be us separating the formula into atoms. Then our next step is count atoms of each element, which is also what we did. Then D, we're going to multiply the number of atoms by the atomic mass. Remember, the atomic mass is what we can find on the periodic table. So however many we have, so if we were doing this one up here, we would take 4 times 15.999996 for oxygen. All right, 12 times 1.00794 for hydrogen. Okay, and then we're going to add up each element from step D, excuse me, to get a total. And then last but not least, we are going to label with grams per mole. This is how we label it every single time. Grams per mole or grams/mole. All right, so at this point, if you don't have it with you right now, you need to get a calculator and your periodic table. I'm grabbing mine, so let's see what we got here. All right, so our first one, we have find the molar mass of the following. We are looking for dihydrogen monoxide, aka water. So our first step says to write the formula. So our first step, we're going to write the formula. We have H2O. So we've now written the formula. Our second step says to separate the formula into elements. I like to do this on a couple of separate lines. I like to give each element its own little line. And what we learn on Tuesday or tomorrow, you'll kind of see why we do that. So that, and then it says to find the number of atoms of each element, I have two hydrogens and I have one oxygen. Hopefully you're staying with me, but if not, remember you can always hit pause and get caught up. All right, so next up, we're going to go to our periodic table and we're going to multiply these number of atoms, however many we have, times their atomic mass found on the periodic table. So I'm going to look for hydrogen. I see, oh, it's 1.00794. Awesome. So we'll play that out. I'm going to wait until kind of the very end to do it all together. So I only really have to pick up my calculator once. Then I'm going to look for oxygen, and I have 15.9994. Earlier, I said maybe a couple of extra nines because, well, it feels like there's a lot of nines there. All right, so here we go. 2 times 1.00794, and we get 2.01588. Okay. And then we have oxygen. Well, one times that, that is super easy. It's just that, right? And we're going to add those two numbers up. All right. And so our answer is going to be 18.01, 1528. All right. Officially, there is a way to do sig figs here, but I'm going to keep it super easy. And what we're going to say is we're always only going to keep two decimals in our answer. So that one looks to the 5. Is it going to go up or stay? It's going to go up. So we're going to say 18.02 grams per mole. So that is the molar mass of water. So maybe up here, label with grams per mole and round to two decimals. Maybe we add that in. Okay. Awesome. Cool. Let's roll on. Now, iron 2 chloride. This one's going to require a little bit of extra work for us, but that's why we do it, right? So it can be challenging. So we have iron, which is Fe. Okay. Now remember, Fe is +2 because of that Roman numeral there. We look for chlorate. It is a polyatomic ion, so we're going to put ClO3. Chlorate is -1. So we got to do our little crisscross thing. So we get 2, 1. So our overall formula is Fe parentheses ClO 3 2. Okay, so this time we have 3 elements, which is not super hard. So we're going to say Fe, Cl, and O. We have 1 Fe, we have 2 Cls, and we have 6 Os. Hopefully you're hanging with me to that point. All right, now we need to find our atomic masses of each. So we find iron, 55.845. Ooh, that 5 looks rough, but I think we'll be okay. Okay, awesome. We have chlorine, 35.4527. All right, let's go ahead and multiply that out. Okay, we get 70.9054. Remember, our goal is to wait till the very end to round each time so we don't get a number that's off. All right, and then we've got oxygen, 15.9994. 6 times that. We get 95.9964. We're going to add those puppies up. Oh man, bummer, bummer, bummer. 5 plus 70.9054 plus 95.9964. We get 222.7468. So now we do our rounding. We get 222.75, and that's going to be labeled grams per mole. And there we have it. Hopefully you're feeling okay about this. It is fairly simple. Let's keep rolling. See you next time.